All right, so let's do some more of this. So then you might handle the token insecurely. One common thing we talked about in previous lessons is HTTPS does not protect you against all attacks. It just stops people from eavesdropping, picking up the transmitted signals and reading the data. The problem is there are attacks like cross-site scripting where you ask the server to send the data to you, and then it works even through the encryption. So of course, if it's transmitted without encryption, then you can sniff it from the same Wi-Fi network or from the router at either end or from the ISP, lots of places. All right. But of course, these days, even a password might not do you much good because a lot of people are using two-factor authentication. So you need both factors. So unless you can steal both factors with something like phone malware that steals the session key, then it would be a lot better to steal the session token after they've logged in, which then effectively is a single factor. And that way the user won't be notified of a successful login. They'll be interpreted as you'll still be interpreted as part of the same session. All right, and this is what happened to me, of course. Even if an app uses HTTPS, it might not always use HTTPS, although very few people are still doing that. Yeah, well, multi-factor, I don't think anybody would say multi-factor is worse than single factor, but it has weaknesses, depending on how you do it. So another thing you might do is you might assign a token as soon as someone connects, and then when they log in, continue to use the same token. And that is, of course, not a very good idea, because then the same token stands for an unauthenticated session and an authenticated session, and the attacker could steal it at the early stages if you send it over HTTP, or sometimes the attacker can even send you a link to click on that will include the token, and you will then log in with that token. That's called the session fixation. So even if you use if HTTPS for everything, the user might navigate back with the back button, and that might expose the token, unless every page on your domain is HTTPS, which is what Google did. Google upgraded so everything is 100% HTTPS everywhere, and that really is the best thing to do. That stops a lot of these attacks. Then there's SSL Strip, which is bloody awesome, a hacking tool from Moxie Marlinspike, where you run this. It's a proxy, and by the way, you can do this with Burp. You can get Burp to make an HTTPS connection and downgrade it to HTTP going to the client. So your browser will be not encrypting it, but it will be the real page, and the server will not know. Now, most browsers will warn you because this is a pretty devastating attack. Increasingly, browsers will block HTTP pages that should be HTTPS. So if your app uses HTTPS for every page, you could send somebody an HTTP link, and if the server does accept HTTP connections, it would then send the session token over HTTP. But a proper server should speak only HTTPS all the way through. That would be the most secure thing to do, but even still, most websites do let you make insecure connections, and then they redirect you to the secure connection, which is a hole. All right, so wander through to do this attack, to evaluate the security of a website. Check all the URLs, check the session token, check where it transitions between HTTP and HTTPS. And I've got a little demo here with vulnerable tokens. Let's see. There they are. Okay. So let's go back to here. Okay. So let's start with this one. All right. And let's bring in Burp, which is here. Get rid of the old stuff. All right. So here you log in with user and password. And I log in. Okay. So here it said welcome user, so it knew who I was. Now the way it did that was when I logged in with the post request, it sent the username and password to the server, and in the reply, the server set a cookie. And here it is, set cookie username 1 equals user. And it just took default settings like the expiration date and so on. So now I have a cookie called username 1 equals user. And if you go here, it sent that cookie up to the server. Username 1 equals user. and that's how the server knew who I was. Now this is a secure page. I also have an insecure version of the same page, which is http ad.samsclass.info. That should do it. That's insecure. So let's go back to this one. Oops, I see, I got it. Whoops, shouldn't have done that. All right, let's do it. Let's just start here. http ad.samsclass.info. And then it's token.htm. All right, the not secure version. So let's try that. Let's clear this old stuff. All right, and now, if I log in, it now knows who I am, and you see it sent it unencrypted. So it sent my username and password unencrypted, and the server replied unencrypted and set a cookie, which I then sent up to the server. So this is the dangerous way to do it. Of course, the old-fashioned way that you won't see that often anymore. So now let's try this one. I log in with user and password. Let me clear the old stuff. All right, I log in, and now it doesn't know who I am. So what happened here? It sent a post request, and it sent the username and password, and the response set the cookie username2. But username2 was set with secure and HTTP only. It just goes right here. Semicolon secure, semicolon HTTP only when you set the cookie. So now the browser was told, remember this cookie, but only transmit it over a secure connection. So when I tried to load the next page, it's not a secure connection, so my request did not send up username 2. It has username 1, left over from the previous example, but didn't send username 2, so now the server does not know who I am. So that's what the HTTP that's what the secure flag tells you. And the HTTP only flag is like this. You could have a cross-site scripting attack that executes this alert document cookie, and see there it pops up the cookies. But here it does not show the username 2 cookie because it's called HTTP only. Because they're separate. You can have HTTP only but not secure, and you can have a secure but not HTTP only. You might want both or one of them. And so the point of this is this is now secure and HTTP only, so you cannot reach it from JavaScript. You can only send it over HTTP, or in this case HTTPS, because I have both the secure and the HTTP only flag set. All right, so that's what I wanted to show you there. And here is the PHP set cookie function, so you can determine whether you want to make it secure or HTTP only in PHP when you send it in. All right. All right. All right. Now, another modern security measure is HTTP Strict Transport Security, HSTS. This is highly recommended. What this does, you set this flag on your server, so every response includes this header, and now it warns your browser that once you receive this header, I only want you to talk to my site over HTTPS. Never come to me over HTTP. So this means after the first time you connect, your browser will never send any data to that server or HTTP anymore, and that's a good idea. It's not perfect, of course. If I could trick you into going to a new domain, then the first time you go there, you wouldn't know that it should be secure. But the first time you go there, you probably don't have any secrets to send it, like your username and password yet anyway. So anyway, this is considered quite good, and it's gradually getting popular. And I checked earlier today, and it was up to 23% of websites using HSTS now. All right, now here's another potential problem. If your cookie might be stuck in a log, and the log might not be properly secured. And I actually found that this is still true, the Center for Disease Control. I found this a couple of years ago, and I tried it again today, and it's still true. Let's just do this one live. If I go to here, and I go to Google and do in URL, JSession ID, right there. This is just an advanced search in Google. So first I find pages about JSession ID, which is fine, But on the second or third page of this, I'm going to start finding pages that accidentally include a JSession ID. And there it is, the CDC site. You can't replace cookie 1 versus 2. The reason why there was cookie 1 and cookie 2 is the first one set a cookie called cookie 1 that was not secure. And the next one set a cookie called cookie 2 that was secure. That's all. When you set each cookie, you specify. So I had a cookie called username 1 that did not have the secure tag, and a cookie named username 2 that had the secure tag. That's all. Yeah, this is in fact the CDC. And the thing about this is if you look at the URL, you see it right up there in the URL, the JSession ID. JSession ID equals all this random junk, stage equals result, action equals hide, measure. You know, and as we mentioned many times in this class, you shouldn't put anything confidential up here in the URL, but they do. And so that means it will be transmitted all sorts of foolish places. For example, it'll be in your browser logs, it'll be in your favorites if you make a favorite, it'll be in the proxy server, it'll be in the referrer logs. If I get you to go to that page and then I send you an IM, hey, come look at my page, and you click on my page, it'll be in the referrer here, because the JSession ID will be included in that referrer and sent to another page by your browser. That's why, putting anything up in the URL is a really bad idea, anything secret. All right, so that's a game here. All I have to do is trick people into clicking on some website I control, and then I'll see things in the referrer if it's up in the URL. All right. Another thing you might do is let people have 2 sessions open at the same time. This is extremely common these days. People can log in on their phone and also log in on their desktop. But you don't usually have the same session token for each of those sessions. If you do, then that's pretty strange. And so here's Flawed Logic. Here's one example. You have user. This is a base64 encoded of user equals daf and a number here. But if I change the username, it'll accept me. So this R1 just means you're authenticated. It's not tied to you. That's another flaw. And it's a big problem these days. Most tokens last for a really long time, often forever. Once you log in, you don't have to log in again. I know on my phone, I almost never have to log into an app. And if I ever hit a login page on an app, I'm pretty much hosed. I say, well, I have to go home and find my password manager and everything. I just quit using that app for a while. So they give you a token and it keeps working for a long time. Now, when you log out, it often just deletes the cookie from your browser, but it does not invalidate it on the server. When I heard about this, it was true of Microsoft Office 365, or I think whatever it's called before it was Office 365, Office Online. And I went and tested a whole lot of websites, and one of the things I did, I found a whole lot of websites that had this flaw, where you could log in, save the cookie, log out, and just come back with the cookie and get back in. So if anybody could ever steal your cookie, they would own your account. And by the way, there's no way to get rid of the cookie at all on the server. And so if somebody did steal your cookie, if you change your password, it does no good. The only thing you can do is close your account and make a new account. It's pretty gruesome, and it's true of a lot of websites. So anyway, now of course, then how do you steal a cookie? Well, you could steal it with cross-site scripting, or you could intercept it on a network if it's not sent encrypted. And then I mentioned session fixation. I could send you a URL that specifies the token, like this CDC website. Right in the URL, I put in this session token. So if I sent you a link to click on, and it was like this, you would go to this page, and I would have determined your session token, not the server. So that's session fixation. I tell you what session token to use. I don't have to steal it. I feed it to you. And now, of course, I know what it is. And then there's cross-site request forgery, where I trick your browser into making a request that goes to my server containing the cookie. I confuse your browser about what site it's on. So here we can talk about the restrictions of where cookies go. So you can set the domain and URL that it's used for. So if I set a cookie by games.samsclass.info, it will be sent to foo.games.samsclass.info, but not to samsclass.info, only to subdomains, which means it has to have all this plus more. So if I have an app at foo that sets this cookie, then it would go to the browser. But if I specify here that it applies to the whole domain, then all subdomains of whaapp.com will see that cookie every time you connect. So if I had blogs and I set a cookie for each user, but if the domain was blogs.com, then I could steal Sally's blog when I'm logged in as Joe. The better way to do it would be to scope the domain to this fully qualified domain and use a different domain name for the main app, and then have this sort of thing. You be careful if you do it right. This exact explanation doesn't completely make sense to me because he would still need a cookie. But anyway, you'd make all the domains different. So joe.blogs.com would not be sent to sally.blogs.com. You can also specify the path. So now it will have to be the domain, and it will have to be viewing a page in that path in the URL. So that sounds good, but the problem is if a person can make a malicious page on the same domain, like that blog example, they can easily defeat it, and there's a web page about that. With an iframe is all you have to do. All right, so this is every chapter has this at the end. They review it all the other way, how you secure things. Make strong tokens, protect them so people can't steal them. Therefore, use a large set of values and a strong form of pseudo-randomness so nobody can guess or predict them. They shouldn't have any meaning or structure. They shouldn't be encoded for a username or anything. It should just be random stuff, and therefore you have to have a database on the server. Even if you use a random number generator, many languages, the default random number generator is not very secure. This happens to a lot of languages like Java and PHP. So you look for things to create entropy. And so one thing that's good is to take these usual clues of semi-random numbers and then add a secret known only to the server and then hash it all. That's a good idea. Transmit over HTTPS like we just did with secure and HTTP only. Don't put session tokens in the URL. And when you log out, invalidate that token. So if somebody comes back in later with the same token, it will no longer be accepted as valid. Sessions should expire. Your book recommends this a lot, although, as I think we all know, most people ignore this because of cell phones. Don't allow concurrent logins. Give them a new token for each session. And if you have high privilege tokens, then protect those tokens, all right, or don't allow them to save their session. Restrict the domain and the path. Watch out for cross-site scripting. Boy, that's a lot easier to say than to do. Almost everybody has cross-site scripting. Don't accept tokens. If you get funny tokens, somebody's attacking you, you should end sessions and block that IP and such. We've talked about this many times. Don't just take stuff like burp repeater, sending up stuff, and accept that. It's easy to tell on the server when somebody is sending junk over and over and messed up cookies. You shouldn't let them do that more than a few times before you block them. Using two-factor authentication is very helpful, and using hidden fields is better than session cookies. You can put a hidden field on each page, so you put it on the page, and then you check to see that it comes back. Now you know that this is a person in a browser viewing the page I sent that one person. It's not somebody else repeating a request. That's a very common anti-CSRF defense, and we're going to see it a lot in this class. Right. Make a new session after every authentication, a different token when you log in, so you can't have session fixation. And so you make a new per page token every time you request a page. It's stored there in a hidden token. So now I know that you really came in from my page and did the pages in order. So it would look like this. You know, each page will have a screen token, just a random screen token, a hidden value in the form. So when you click submit, you're sending it up, and you would only have it if you're really coming in a browser clicking the form that I put there. If you're doing things out of order or with invalid tokens, this should be considered suspicious, and you should be warned that somebody's trying to hack into your account. You should warn the user, and you should block that attacker. And so if you have any goofy stuff coming up, you should terminate the session. If the hidden form field is not there, or they're messing with They're adding dangerous characters that look like SQL injection or cross-site scripting, or so on, violating length restrictions. There's plenty of clues that somebody here is using burp. They're not really using my web page as intended, and you ought to terminate such a session. All right, so let's take a look at the last cahoots, which will be here. All right. How to recognize which is a bad token? Well, the thing that makes it bad is that you can somehow predict it or guess it. Sometimes that's obvious, like it's just counting numbers. Often it's not, and you have to try all these attacks to see that it has a weakness. All right. All right. So what does HTTPS prevent? Yeah, it prevents eavesdroppers that are sniffing their transmissions. They can pick up the transmissions, but they won't be able to decrypt them without the key. All right, what prevents users from clicking through an SSL warning, which studies show most users will do. If a box pops up and says there's something wrong with this connection, they will just click OK to proceed with their work. That's one thing HSTS does. People will always send things over HTTPS, and it will not accept broken HTTPS. It will not even offer you the chance to say, oh, ignore that, and let me go anyway. Yeah, of course, everybody does. All right, anyway. All right, which defense will stop people using JavaScript to steal your cookie with cross-site scripting? Yeah, that's HTTP only. Then you can't use JavaScript. And by the way, that Jordan saying guilty reminds me, there was a time when the college's main login page had an SSL warning. This keeps on happening, where perfectly fine pages, you forgot to renew something, it's out of date or something, you get a warning. So most of the time, you do just click through that box and it's okay. And most security products like firewalls use broken HTTPS. you connect, and then you have to click through the insecure warning. So it's pretty, it's very common that people click through those warnings, and we're all trained to pretty much ignore them. Anyway, that's the point of HTTP only. You cannot get it from JavaScript, and therefore cross-site scripting will no longer work. All right, what should a logout button do? Yep, that's what it ought to do. Terminate the session on the server. It very frequently does not. All right, what kind of token is not sent on every request? All right, the hidden fields are only coming from that one page, instead of sending it with every request to the server the way cookies are. And that's why you combine the two to make sure they're actually coming from your page, and when they come to page 2, they come to page 3, they really came from page 2, and so on. You put a hidden field on the page, and then you know if this request really came from someone viewing the expected page, as opposed to something foolish like trusting the referrer. All right, so what should happen when you receive a request with a modified hidden form field? Yeah, terminate the session. This is a bad person attacking you with burp. This is not a user making an honest mistake. All right. All right. All right. Ah, all new winners. All right.